Hey everyone, I'm Maciek. I was just wondering if there's anyone here that actually doesn't speak Polish and this is helpful for them. We have one. Then it's well worth it. Okay. Um, so that's the title of the presentation: type safe serverless, pre-serverless APIs. And you might be like, what is going on? Like what are all these abbreviations and like kind of buzzword bingo going on? So don't worry about that. We'll go into this. Kind of bring everyone up to speed before we jump into the meat of the presentation. Few words about myself. I work for a company called Pleo in Denmark in their FE platform team. Been a while doing web stuff, like remember Backbone with CoffeeScript? Anyone up here remembers Backbone with CoffeeScript? Yeah, good times. Yeah, I lived in Denmark for a decade, moved back to Poland a while back. You can find me online, and I like things that starts with B. All right, this is a slide that I would like to see in many presentations, which is kind of like where you are in the, at least in these two dimensions of software engineering. This is kind of me. So I've mostly worked at product companies, so where it's a lot about maintaining and it's bigger teams. Haven't really explored like this space around ship and down, which could be like agencies and software houses, stuff like that. Or none of my side projects went viral, so I had to maintain it. I think it's helpful to understand that all I'm saying is I'm saying from this perspective, and if your perspective is different, your mileage may vary. What's on the menu? We have for bingo, so explaining some of these things that I talked about in the beginning, or like the title presentation, a bit about the architecture that I kind of proposed here, a deep dive into our implementation of Pleo and some guidelines and learnings if we have time. All right, buzzword bingo, jumping straight in. Kind of, I want to go through this pretty fast. Hopefully just kind of bringing people up to speed. Starting with something very simple, single page applications. You probably all know this. It's a web app client architecture. I think the defining thing is that all the rents and all the routing happens on the client. So like most of the code that is around actual rendering is happening in the user's browsers. There's no really servers involved for rendering. And usually it's served as static files from something like a CDN. Actually, like these two talks that we had before, some of these things you will see kind of coming back here, so that was really nice to go through that before. It's definitely not what the cool kids do anymore, and there are good reasons for this, especially issues around performance, accessibility, kind of dev efficiency, how much you can do with that paradigm. There's a really good article that I link to here. Recommend reading that if you haven't. I think this embodies kind of what SPAs are. It's from Sentry. This is roughly how the HTML they ship. At least they're honest about this. So why do we talk about SPAs in 2022, almost 2023? Since you know it's kind of like a decade-old thing. They're still pretty simple to build and deploy. It's been a standard, so there's a lot of SPAs out there. So if you work in a product company, you might meet them. So it's still worth like not only about the new stuff that's upcoming, but also about stuff that we kind of stuck with. Next buzzword, BFF. So cue in all the jokes about best friends forever, but in this context is Backend-For-Frontends. So it's a pattern of communication between backend and frontend. So it kind of, at its core, it's about decoupling the client apps from the underlying services. Usually this comes up in context of microservices architecture. So we kind of get a dedicated place in our system for this aggregation and transformation logic. You can imagine making a few requests to different APIs, combining that, maybe doing some light transformation and returning it to the server. What's also important is that it's kind of coupled and it's very exclusive to this one single user experience. So for example, if you have a mobile app and you have a web app, then you would have two separate BFFs for that, because they would be coupled to these two different user experiences. I think originates from SoundCloud around 2015, so also nothing new. And there's an article from that time by Sam Newman. I also recommend reading that. And a very nice image from SoundCloud when they introduced this. It kind of shows you like these colored boxes are microservices. They also had like one monolith with some APIs. But then you can see these BFFs for different experiences. There's actually quite a lot of BFFs out there, but very few are actually like explicitly called BFFs. If you consider two kind of cool frameworks these days, Next and Remix, in both of these cases you can meet BFFs if you use the get server-side props or the loader function in Remix if you use it to just perform API requests. So if you don't have database queries straight from these places, but instead kind of call in to some underlying microservices, that's just BFF, right? And Remix actually even has like a specific guide for BFFs, and they tell you that yes, it's possible to do that with Remix. Something that comes up a lot in this case, what about GraphQL? It's like conceptually very similar. I would say it's compatible with this BFF architecture. You could see it as BFF on demand, you could say. So I kind of create my own BFF when I make a GraphQL query, right, from the client. I think there are some problems with GraphQL in that it's not very easy to get right. If you happen to have like a GraphQL expert on your team, then it might be a good choice. But it might be hard to introduce for especially in bigger, kind of more established projects with some legacy of mismatch between entities in different services and stuff like that. Moving forward, serverless and Lambda. Very, very high level overview of what that is. You could see it as backend services on per use basis. The kind of underlying mindset here is that it's just a function you call in the cloud. AWS Lambda, probably kind of the most popular offering here. Kind of popularized this whole concept. It's actually quite popular for front-end facing stuff. If you think about Vercel, Netlify functions, it's Lambdas with some abstraction on top of them. If you want to use, like you can call Lambdas in many different ways. If you want to call them via HTTP, then you have two options. One is AWS API Gateway. It's kind of a very elaborate solution. Quite a lot of Terraform you need to write there to get that running. Or you have something very simple and quite new, which is Lambda URLs. I think it actually came, kind of was published or made generally available this year. Good option as well. There are some possible performance issues around cold starts. Every Lambda skeptic will tell you. And the cost depends on use cases to monitor it. And the last buzzword, tRPC, probably the newest one, so the most buzzing. It's a really, really great library, TypeScript library, you could say, for building type-safe APIs, made by this great guy, Alex. It requires you to have a full-stack TS monorepo, so both front-end and back-end in one repo to kind of reap the benefits. An awesome part of it is that with no code generation, just kind of inferring shared types, you get this type safety between your client and your backend. It's optimized for data fetching from the browser, so it does some cool things around, for example, batching requests. So if you make multiple requests to your tRPC procedures kind of at the same time, it will just perform a single HTTP request. I will talk about that a bit more later. Yeah, and it doesn't try to come with their own solutions for things that they don't have to. So they integrate really well with stuff like Zod for kind of schemas and React Query for performing the requests from React. So if you already know these, then your migration is much easier. Good thing about it is works with any JS framework. They have really good adapters for React, but you don't have to use React. And works with any JS runtime, like the server side of it. You can run it in Express, in some Docker, whatever, Kubernetes. But you can also just deploy it to Lambdas, which is what we're gonna see here. And it is definitely what the cool kids are using right now, also for good reasons. I have this little video here, that you can see. So this is tRPC in action. What you see here is that on the left we have the server side, on the right we have a client side, and what just happened is that we just changed the definition of what we expect the client side to pass as query parameters. So if we play this again, we change from message here to name, and you suddenly have TypeScript errors both in your backend code and in your frontend code. No code generation, right? That's kind of the power of tRPC and the reason why it's. All right, so buzzword bingo is done. Now let's move on to some of the meat of this presentation. So stuff around architecture. I have this thing right on top of the text. There you go. Back and front end communication with SPA. So we have three different options here. First one is basically the default case, I would say. So you have some microservices, A, B, C, D, and you have your SPA running in the browser. And then if you need to fetch something, you just make a request to the microservice, right? The problem with this is that this gray area, users network, you don't want to go for that too much, because it can be slow, it can be unreliable, and it's definitely like physically far away from the server. So your latency is going to be larger, right? Kind of exemplified by these stack traces here for network calls. So they're all gonna be quite long, right? Because of the latency and maybe slow network. Another option is you move some of that logic of aggregation to one of the microservices. So what you solve is the kind of a slow waterfall problem. So now you have kind of what's in the browser is just this A request underneath, and that's distributed stack tracing. We've seen that you get kind of requests to other services, sorry. That's kind of okay, but the trade-off here is that we now have a coupling between our client and that one microservice. And that's problematic because kind of, what if we have another client, like a mobile app, with its own needs for data, and then suddenly this A service becomes like not really a microservice anymore, right? Because it both has some database and it's fetching from other services. It needs to understand what the clients need, kind of grows and grows, and you end up with this kind of a Frankenstein of a microservice. So what's the third option? No surprise, the third option is the BFF. So in this case, we have a dedicated BFF service, which does the aggregation and then sends stuff to the SPA. We still get the benefit of like a single request going through that gray zone of users network. We still get the nice, kind of nice short stack traces. And we don't have kind of these Frankenstein services, all of them are still proper microservices, and the BFF is kind of, it has one purpose, right? And kind of a clean architecture here. So that's what we're going for. Moving forward, so a few principles that you can use when you now kind of want to design a solution for this BFF, for the SPA. I listed 4 that we used, but there were definitely more, just to kind of keep us on before midnight. Automatic immutable deployments, what I call translucent abstraction, optimized for calling APIs, and not an architectural sidestep. So let's dig into these. So automatic immutable deployments. So what we want is we want to deploy the SPA and the BFF, so both the client part and the server part of this together. So that the SPA can always talk to the exact same version of the BFF that was deployed with, right? And all that versioning that happens automatically. That's our requirements for this. What we get back, if we kind of keep those requirements, is that we get very easy rollbacks. We don't have to think about, okay, I'm rolling back the client, but then I also have to roll back the server. Or if I roll back the server and going to roll the client, they're all coupled together, right? They act as one entity. We can break whatever we want, because the apps kind of, if my user has the SPA opened in a tab, it will continue to work even if I like completely change the server, right? Because it will have its own version of the BFF that it can talk to, and the newly deployed app will talk to a different version of the BFF. And that idea is kind of summarized here, right? So we have microservices stay the same, but we have 2 BFFs, version 1 and 2, talking to 2 SPAs, version 1 and 2. Translucent, so semi-transparent abstraction. The transparency part here is that it should really feel like an integral part of the app. It shouldn't be a separate thing that we need to think about, like a separate PR we make somewhere, coordinate releases, stuff like that. There should really be like minimal friction to the development process, including like you don't really have to run some kind of code generation step for every change you make. The not transparent part, like we don't want to completely hide the fact that it's a server. The developer still needs to know that it's some part of the code runs in the browser and some part of the code runs in the server. Otherwise, like it's a little bit dangerous. They need to understand, for example, that they can ship a like a server-side library to the client. Of course, there are safeguards for preventing errors, but it's good not to hide that fact. That kind of uniformity here is showing it as a simple diagram here. So like you have BFF and the SPA as kind of a single entity. Optimizing for calling the API, since we've seen that's basically all that we're going to do in these BFFs. So we're going to call some APIs and aggregate and transform the data. It's important to optimize for this particular thing in terms of developer experience. You can think about things like if the user is authenticated, passing some kind of token, we don't put it on the developer token forward, right? That should be done automatically by our framework, right? Stuff like calling the actual services, underlying services, like if we actually want some type safety, there needs to be some type clients there as well. And you can optimize performance with caching, probably not caching between requests, but caching on the level of a single request. So for example, opening a TCP connections or caching DNS lookups, or even if you like within a single user request, we call the same endpoint multiple times, would be nice to cache that as well. Perhaps a related thing here is optimizing that layer between the SPA and the BFF. was difficult to draw, but that's kind of what the tRPC library does for you, right? So multiple requests get batched into a single HTTP call that goes through the user's network. Then it's kind of unraveled, and then like multiple microservices are called by these multiple procedures. And the last principle, that it's not an architectural sidestep. So we do want to kind of work towards a framework like Remix or Next, maybe. We don't want to go completely different way, make it more different. If you have an SPA, maybe you want to start doing server rendering or start using a Remix. But I think this particular thing is actually good for that, right? Because it simplifies the views, takes some of the business logic, some of the aggregation logic out, making them more portable. I can put that view then in Remix app, I can put it in the next app, and it should kind of be already ready for that. And a requirement that is incrementally adaptable. They don't have to stop the world and rewrite the entire app just to use it. I can use it, like, for example, only for the new stuff that I'm building, or like slowly move back and port to old stuff. Yeah, so let's jump into kind of our implementation of this pattern. A few lessons, or maybe like lessons to answer later. For now, let's just kind of take a deep dive and then look at some code. First of all, this is not my project. I worked with two amazing engineers, these two handsome guys, Kenneth and Xavier. So this whole project is kind of our brainchild between the three of us. And of course, it's all based on the tRPC library. So Alex gets credit there. So state before we got to the BFF, right? We have an SPA built with Vite, deployed via GitHub Actions to S3 and CloudFront, kind of things that we've seen in the previous presentation. Uses React, SWR for fetching right now, and React Router. And what we do is we split by feature. So we have kind of these sub-apps in directories. For now, it's only per directory. We don't have like a monorepo support that has separate builds. Yeah. SWR, it's a library for fetching data. Yeah. If you know React Query, it's basically the same. And that's also why we're doing the split, the switch. We kind of thought whether we should try to use SWR for this setup, but we decided because it's almost exactly the same API, it's fine to just switch to React Query for this. All right, so the structure of the sub-apps feature in the app. So we have two little sub-apps for Christmas and Easter. And when we add the BFF, this is how it looks like, right? So we just integrate this server-side stuff on top of the existing single-page app. Things to note here. In the BFF directory, which kind of lives as a sibling of the sub-apps, we have stuff that is needed for this setup to work. And then for each of these sub-apps, we have, by convention, a backend directory, which is where all the server-side code for that particular feature lives. So kind of going into these files one by one, just to see what's there. The first one is this tRPC, which is the tRPC setup. This is where we create an instance of tRPC on line 12, and we give it a context type. Context, that's basically all the stuff we put into every procedure call as kind of convenience for the developer. So in this case, we're giving them configuration, a logger, user, which is maybe a decoded user from the JWT token, and API, which can be used to call different microservices. And we use the helpers from tRPC to infer the type of this context, and then we pass it to the tRPC instance. So then when we actually call these procedures, we have the context properly typed. The router, or the root router, that's where all the sub apps are mounted. So you can see we have both the Christmas and the Easter sub apps kind of mounted here. You can expect this file to grow as we add more features to the BFF. The handler, that's what we give to the Lambda, and that's kind of the entry point to the server-side part of our app. Basically kind of combining the router and the context stuff and using the tRPC Lambda adapter. You can see on the first line, something that tRPC provides us is an adapter to run tRPC in a Lambda. All we give it is like, give it our root router, give it our context, and it does the right thing. Offering procedures inside a sub-application, this is how it looks like. So we basically pull that tRPC instance that we just saw in the previous file. Then we can call things on it. For example, we have a procedure to create a procedure. We have a gingerbread man procedure here, which for now just returns some static stuff. We'll see how to add content here later. And then we create a router. You can see we can nest these routers, and we're using this to add a prefix. So we have a prefix Christmas for this particular sub-application. And this from on line 8, that's what's used in the root router. And on line 11, we export a type. And this type is important to use in your single page application. So kind of on line 4, this is the tRPC magic. That's kind of your magical moment. This is where we cross the boundary from the client to the server. The only time we do it, where we import something from the backend. And the only reason we can do it is because it's a type import. So specifically, we just imported the type. So that's compiled away on the build time. And on line 4, we use that to generate these React query hooks. And then we use them on line 15. You can see we kind of unwrap this router nesting that we had there, so Christmas, gingerbread man. Then we use query, which is a call to the React query API. And then we can use that. And the magical thing is that on line 18, data, this is typed. So hello will have because we used to specify it here as true, and it will have a type of Boolean. Yes. So how do we use the context that we saw? So for example, we can get some user info from the JWT. You can see that on line 3. We have these pre-configured API clients, so we call like a dough service or ginger service. We make these API calls, and then we have a logger, and which is also kind of pre-configured to send the logs to the right place and all of that. When it comes to generating these pre-built typed clients for services, you can see line 5 and 6. That could be a separate presentation. For what we're using this library called Orval. So that takes an open API specification of it and generates a typed client for your service. There's many ways to do it, but unless you do it, then you don't really get full stack type safety, right? Because it kind of just stops at the BFF. When it comes to development, so how to run it locally, you can go for a sophisticated tool like localstack.cloud that can basically recreate AWS on your local machine. Or you can do what we did, write a little wrapper that turns a HTTP request into a API gateway proxy event. So that's basically what the Lambda URL does under the hood. It's not open source yet, but we probably will do that later in this next year, actually. A bit about building this. So when it comes to building it for deployment, we use ESBuild. Just give it that handler file, and we'll bundle it together for Node. So you will get one single file that you can then deploy to Lambda. Deploying. we have most of the code terraformed, except for these parts, because they are dynamic, right? So we get a new version of the Lambda for every deployment, so we cannot really terraform this. But what we can do is we can take the code that was built, compute a version of it, so kind of get a hash of what's inside the file, and then create a function, and then create a function URL, send that to AWS. What we get back is on line 19, you can see we get a URL. And then you can use that URL to call our procedure, and you get the data back, right? So that's kind of how it works in the browser. Of course, you don't interact with it like this. The only way you interact with it is via these auto-generated hooks. But if you want to know kind of how it works under the hood, that's how it works. Time. How are we on time? All right. We're a bit late here, but let's see. Guidelines and learning. So a few things that kind of we saw people using this setup and decided that these are good recommendations for how this setup should be used. So the first one is that when you divide your BFF into these procedures and routers, like, only look at the UX. So don't look at, for example, where the data is coming from. Don't think about like what's already available in the app. Don't look at the code structure of your React components. Don't do that. What do instead is like look at your designs, or you look at your app and look at things like what parts of the UI are close to each other, what parts of the UI show on the screen at the same time. What is the priority? So maybe some of the data is more important to be visible than some other stuff. Like if I go to a page for gingerbread man, I want to see the gingerbread man, right? I don't want to see the Santa Claus or whatever. Cross dependency, meaning if you have that waterfall, if you need to have it, move it to the BFF. Don't do it on the client. And latency, perhaps some of your microservices have like largely different latency characteristics than some other. It makes sense to put in separate procedures so that the user sees some of the data as soon as possible, not wait on the slowest thing in the pipeline. There's an example from our app, kind of just looking at the screen, I can already try to identify what routers and what procedures I will need, right? Like in this case, in the middle, that's kind of the meat of this page. It's the list of expenses. I want that fetched as soon as possible, so I make that into a separate BFF procedure, right? If I have some filters, they only show up if the user clicks on the button. Makes sense that for that to be a separate BFF procedure. Another kind of lessons learned is that you should apply the same philosophy that we apply to the BFF itself. So we have one BFF per user experience, also to BFF procedures. So you have one BFF, or each BFF procedure is only used by a single piece of UI. So don't reuse these. I think that's like trying to be dry about everything. So like only have one implementation of something, not copying code. That's kind of a sickness that we have as a software development community, I would say. Just embrace it. It's fine to copy paste. It's going to be easier to maintain than wrong abstraction. If you really need to share, there are some better ways of sharing than just sharing the procedures. For example, you can share a component that is connected to a BFF procedure. Don't share the procedure for multiple components. Or don't share the procedures, but share the logic, kind of just as pure functions underneath in your BFF. And probably the best thing, if you happen to see that something is like over and over again, you copy it like across different procedures or even different BFFs, it's probably business logic and should live in an actual backend and not in a BFF. Getting close to the end. So translate business logic into view logic in the BFF. What I mean by that is don't do this. So in this case, we are pulling some settings and then returning like very vague business logic kind of related fields to the front end, and have some logic in the front end to decide like what to show depending on like role and plan and color and stuff like that. Instead, like use the BFF to already do that. Turn the business logic around, roles and settings into a view specific thing. So in this case, like maybe we have 3 different modes of the UI, and that's what we use this data for. Don't have that logic in the UI, have it here in the BFF. And the UI can be like a simple switch statement, basically, right? You just get some view mode, and then you render different view modes based on that value, right? And I think that's the last one. So prefer primitive types for React components props. That's something that that happens. Like people have this tendency of wanting to propagate these types through their apps. You can actually do that in tRPC. There is an infer procedure output type tool. So we also seen that like use of generics. So we can plug our procedure type, and we get the response type back. So we can basically know what the procedure returns, right? And then we can use it as a type of some props, right? The problem with that is that now our gumdrop button component here is tied to a BFF that it doesn't even use. So if you test this component, if you storybook this component, like you suddenly tied to this very weird interface. Instead, what you should do, like, get rid of that dependent BFF as fast as possible, right? So that your components down the tree, they don't know about it. And this is also where the duck typing comes in. Like, it doesn't really matter if the shape matches, you're gonna be fine by TypeScript, right? So use that to your advantage here in terms of architecture. And that's it. Thanks a lot.
Okay, do you have any questions? Maybe okay, I see a lot of questions. First, you.
Thank you for this wonderful talk. I have one question and one question only. Is it Remix yet?
No, it's not. It doesn't have the server-side rendering. It doesn't have. It doesn't integrate with the router. You can do some of that now that we have React router data loading hooks. We could integrate that here. So this is like a very, very poor man's Remix, I would say. But it's a step on the way, right? If we want to get to Remix, we can, and this takes us closer to that goal.
I meant the other way around. Can you use tRPC in Remix?
Oh, can you use tRPC in Remix? Well, I think they actually have an open issue in the Remix repo around building Remix loaders with tRPC. I don't know how far that effort is, but there is definitely some synergies there, and I hope that in the future that's possible, so that our migration would be even easier. Our tRPC procedures, and we plug them directly into Remix, right?
Okay, next question. Okay.
Well, in my opinion, that was a true DevOps. But I have to ask you, how does your team looks like? Because in my opinion, this is a very clever code, and it's too clever. It's like it's too seniorish. You need to grasp a lot of things mentally in order to develop one single feature, because a lot of responsibility comes to you as a single front-end developer. Because right now, supposedly, you cannot be a front-end developer in your team. You always have to be a full-stack developer, like the Lambda, CloudFront, Backend, BFF, frontend, like everything in one feature. And I wonder, do you have juniors in your team? And how do you introduce a new people that aren't, egghead, folks that are like 10 years in our industry? Because there is, in my opinion, a huge like entry point to your technology. And I don't say it's bad or something. I think it's a very great tool for doing particular stuff. But I'm kind of scared if I were to join your team.
Yeah, I mean, if you were to join my team, which is the front-end platform team, you would definitely need to understand all the tools you mentioned, right? So you have to understand S3, CloudFront, Lambdas, all of that, right? To contribute features to the product, I think that was one of the principles, which was it was almost a transparent abstraction, right? So you basically do the things you did before in your client code, you just move it to a different file. You need to be aware that it runs on the server, but from the perspective of kind of code offering, it's not a much different experience. And we put a lot of work into making sure that it's not. In terms of being full stack, I think that's just generally how things move right now. If you lock yourself in a box of a front-end engineer where you can only do code that runs in the browser, I think you're in for a bad time in the coming years, because the general kind of zeitgeist is that moving towards kind of back in time to the times where a lot of stuff happens on the server and kind of thin clients are just there to render some stuff, right? And I think, proper full stack is like databases, APIs, all of that. That's not it, right? We still have backend developers doing microservices. Does that answer the question?
Okay, do you want? Okay.
I want to know how you, with this server side and front-end side approach in one repo, how do you go about testing? Like, do you test server side separately and front-end side separately, or if it's all together already, do you test it all end-to-end?
Yeah, that's a very good question. And we are a little bit torn there. So before we introduced the BFF, our setup was we had, of course, like some unit tests, but the main kind of protection layer was our Cypress tests. So tests that run in a browser and kind of click as if you were the user, and they mocked everything on the browser network layer. Which basically means like we mock the responses from the microservices, but everything that happened in that repo was covered by this test. Introduction of the BFF made that more or less impossible, right? Because now if I mocked in the middle of the browser layer, I mock the BFF, right? And it's not trivial to put the mocking behind the BFF, because the BFF, like that would require us to go out of the Cypress framework, and we might actually be doing that in the future. So far, like right now, we do mock the BFF, and we have separate functional tests for the BFF, right? So we call procedures and we assert on the responses. What's nice there is that it's a very simple thing to test. It's basically a pure function, right? There's no state, nothing like that. You just like make a request, mock a few endpoints from the microservices, and you just look at the JSON response, right? Pretty simple tests.